A train cuts through the open grasslands of Kenya, crossing the entire length of the country in under 5 hours. Below it, lions roam, elephants walk. The wild savanna stretches out in every direction, but this train isn't on the ground. It's flying above all of it, gliding along a concrete track elevated high above the earth, crossing rivers, valleys, and national parks without touching a single inch of protected land. This is the Kenya Standard Gauge Railway, and it is one of the most jaw-dropping construction projects ever completed on the African continent. Here are the numbers. The railway stretches nearly 500 kilometers. It was built in less than 3 years. It cost $3.8 billion. And almost every single piece of it, from the steel rails to the concrete pillars to the locomotives themselves, was engineered and delivered by one country, China. But before the engineering, there is a story. A story of a country desperately stuck in the past and a global superpower that saw an opportunity no one else was willing to take. Kenya sits on the eastern edge of Africa. Its capital, Nairobi, is one of the most important cities on the continent, a hub for business, technology, and diplomacy. On the Indian Ocean coast sits the Port of Mombasa, one of the busiest ports in all of Africa. Every day, massive cargo ships arrive carrying goods not just for Kenya, but for landlocked nations hundreds of kilometers inland, places like Uganda, Rwanda, and South Sudan. But getting those goods from Mombasa to Nairobi, a journey of roughly 500 kilometers, was a logistical nightmare. The old railway running between these two cities was built by the British over 100 years ago during colonial rule. It was never upgraded. Trains crawled along at speeds that felt more like a bicycle ride than a freight service. A trip that should take hours could drag on for more than a day, sometimes 2. Trucks were only slightly better, clogging the one main highway, breaking down in the heat, and driving up prices for everyone. The cost of moving goods from the port into inland East Africa was ranked among the highest in the entire world. Local businesses paid more to move a single container from Mombasa to Nairobi than companies in Europe paid to ship goods across entire countries. Think about what that means for a country trying to grow. Every product arriving through that port gets more expensive by the time it reaches people who need it. Farmers cannot sell their produce fast enough. Factories cannot get raw materials on time. Clinics in rural areas wait longer for medical supplies. Small shop owners watch their profits disappear into transportation costs they have no control over. And the older this colonial-era railway got, the worse things became. Tracks warped in the heat, bridges crumbled, whole stretches of line became unsafe and were simply abandoned. Kenya needed something bold, something completely new. In 2014, China made Kenya an offer that was almost impossible to say no to. China's Exim Bank, a state-owned financial institution, offered Kenya a loan of approximately $3.8 billion. The China Road and Bridge Corporation, one of China's most powerful construction companies, would handle the entire project from design to delivery. China would bring engineers, technology, and its workforce. This was part of something much bigger, China's Belt and Road Initiative, a sweeping strategy to invest in infrastructure across Asia, Africa, and beyond. Not out of generosity, but as a calculated long-term move. When China builds a railway in Kenya, it exports Chinese steel, deploys Chinese machinery, collects loan repayments over decades, and builds diplomatic relationships that shape trade and politics for years to come. Some call it smart diplomacy, others call it economic strategy. For Kenya, the result was the same, a railway that would never have been built otherwise. Before a single bulldozer moved, Chinese engineers flew in and began surveying the entire 500 kilometers route using satellite data and aerial aircraft. They mapped every hill, every valley, every river crossing. They calculated where elevated sections would be needed, where the ground was soft, and where the terrain demanded special engineering solutions. This planning phase alone involved hundreds of specialists working across the landscape for months. Tens of thousands of workers then arrived on site. Heavy machinery moved across the landscape like a slow-moving army of progress. Before a single rail could be laid, engineers had to deal with one of the biggest challenges on the entire project. Kenya's landscape along the route is mostly flat savanna, with stretches of loose sandy soil that shift and crumble. You cannot pour concrete on top of sand and expect a railway that weighs hundreds of tons to stay straight and level for decades. So the first battle was not against distance, it was against the ground itself. Hundreds of bulldozers moved across the construction zone, flattening hills and filling in dips to create an even surface. But flattening the ground is only the beginning. Loose sand doesn't hold weight well. If you build on it without treatment, the entire structure will eventually sink, shift, or crack. To solve this, engineers pumped water into the sandy soil through long spraying arms stretched across the site. When sand gets the right amount of moisture, its particles start binding more tightly, almost like adding water to dry flour. The surface becomes denser and more stable. Once the moisture reached the right level, giant cranes lifted a steel weight, sometimes as heavy as a medium-sized car, and dropped it straight onto the ground. Over and over, the impacts created shock waves that traveled deep into the soil, squeezing out the air gaps that make loose ground weak. After enough drops, massive rolling machines drove back and forth over the surface like giant irons pressing a shirt flat. Workers then spread a thick layer of Kenya's characteristic red soil across the surface, compacted it again, and the process repeated. Layer by layer, what was once soft shifting savanna sand became a hard, dense foundation strong enough to hold cranes, concrete mixers, and massive steel structures. This entire process had to be repeated across hundreds of kilometers of route, section by section, in temperatures that regularly climbed past 30 degrees Celsius. Here is where the project becomes truly extraordinary. The Kenya Standard Gauge Railway is not a ground-level track. Most of it is elevated. It runs on top of thousands of massive concrete pillars, each one roughly 15 meters tall, about as tall as a 5-story building. Each pillar weighs close to 90 tons, and they are lined up one after another about 35 meters apart, stretching as far as the eye can see across the open plains. From a distance, it looks like a giant concrete centipede crawling across the landscape. Every single one of these pillars was built on site. Workers assembled steel molds, filled them with high-strength concrete reinforced with steel bars, and let each column cure before moving to the next thousands of times over, across hundreds of kilometers. In the blazing Kenyan heat, each pillar had to be placed with precision, because even a small alignment error would throw off the entire bridge deck above. Once the pillars were standing, the next challenge was connecting them using what engineers call precast girders, giant concrete beams about 30 meters long, weighing up to 100 tons each. Each girder was cast in a factory yard near the site, reinforced with high-strength steel cables stretched tight before the concrete was poured. When the concrete hardened, those cables pulled against it from inside, making each beam many times stronger than ordinary concrete. A specialized machine called a launching gantry then moved along the tops of already built pillars, reaching forward to pick up each girder and set it precisely in place. The tolerance for error was just a few millimeters on a beam weighing as much as 10 full-grown elephants lifted high above the ground. One by one, beam after beam, the bridge deck grew 30 meters at a time, day after day, kilometer after kilometer. By the time the elevated sections were complete, Kenya had a structure that crossed national parks and wildlife corridors without a single road crossing, fence line, or disruption to animals. Elephants still walked freely. The Nairobi National Park, which sits right at the edge of Kenya's capital, was crossed without a single animal being displaced. The railway flew over it all. With the elevated structure complete, the next job was laying the rails, and this is where the scale of industrial production becomes genuinely hard to absorb. Steel rails don't come out of the ground already shaped. They start as thick steel blocks called billets, each weighing several tons. These are loaded into massive industrial furnaces and heated to around 1,200 degrees Celsius. At that temperature, steel doesn't shatter when hit. It flows. It can be shaped. From the furnace, each glowing billet is fed through a series of rolling machines that work like a pasta press but for metal. On the first pass, the steel is squashed slightly and stretched longer. Then again and again, each pass slowly forming the exact cross-section of a railway rail. A wide flat base, a narrow web in the middle, and a rounded head on top where train wheels will eventually roll. By the time a billet finishes this rolling process, it has stretched from a block just a few meters long into a rail stretching up to 100 meters the length of a football field, made from a single piece of steel shaped under enormous pressure while glowing red hot. The rails are then cooled carefully, straightened, and cut to standard lengths before being shipped to the construction site. Below the rails sit concrete sleepers, rectangular blocks about 2.5 meters long, each weighing between 250 and 300 kilograms. Made from pre-stressed concrete with steel cables stretched inside before pouring. Every sleeper comes fitted with metal clips, plates, and bolts to hold the rail firmly in place against the enormous forces generated by a loaded train hitting the brakes at full speed. Every single kilometer of this railway requires between 1,600 and 1,700 sleepers. The entire line is 472 kilometers long. That is hundreds of thousands of individual concrete blocks, each one manufactured, transported, and installed with precision. Rail sections were pre-assembled into modules of about 12 to 15 meters, each containing around 20 to 25 sleepers, before being craned into position on the bridge deck. Once down, each module was aligned to maintain the standard rail gauge of 1.435 meters, a measurement so critical that even a tiny deviation would make the track unsafe for trains to use. Once the rails were clipped into position, crews used a process called thermite welding to join adjacent rail ends together. In thermite welding, a chemical reaction produces heat so intense it melts steel, fusing two rail ends into one seamless piece of metal. When done across the entire line, the result is a single continuous ribbon of steel stretching hundreds of kilometers with no joints, no bumps, no weak points. Trains can fly over it at full speed without rattling or vibration. When the first train rolled from Mombasa to Nairobi in 2017, the journey took approximately 4.5 hours. The old colonial-era railway, when it even ran, took more than 24 hours for the same trip. That is not a small improvement. That is a complete transformation. Goods that used to sit in slow-moving trucks or ancient rail cars now move quickly and efficiently from the coast into the heart of East Africa. A trader in Nairobi can now order goods arriving at Mombasa port and expect them the same day. A family traveling between the two cities no longer needs to budget for an overnight journey. The project employed tens of thousands of Kenyan workers during construction, many of whom gained skills in modern engineering, machinery, operation, and technical maintenance they had never had access to before. Local engineers and technicians were trained to operate Chinese-built locomotives and signal systems. New stations became hubs of activity in communities that had never seen modern transportation infrastructure before. Towns along the route began seeing more economic activity as goods, and people moved through them at a pace the old system could never support. Students, workers, and tourists suddenly had a fast, reliable, and affordable transport option that simply did not exist before. The wildlife corridors beneath the elevated structure remain fully intact. Animals move freely across the savanna below while trains pass silently overhead. Is the project without fault? No. Kenya took on significant debt to build it, and questions about long-term repayment are real and ongoing. The economic sustainability of the project continues to be debated. But in terms of what was actually built, the speed at which it was done, and the scale of engineering involved, it stands as one of the most remarkable infrastructure projects in modern African history. A 100-year-old British rail line, crumbling and forgotten, replaced by a floating highway of steel and concrete that glides silently across the East African plains. That is not just infrastructure. That is a country reshaping its own future, one concrete pillar, one steel rail, and one seamless weld at a time.